Somewhere beyond the edge of the solar system, a whisper of energy on the order of a billionth of a watt crosses the void for almost a full day before it reaches Earth. That whisper is the voice of a probe launched in 1977, and every time it arrives, it could be the last. What has kept this conversation alive for nearly half a century is a precarious balance of physics, engineering, and human stubbornness. And it's precisely this ever-weakening threat of a voice that forces us to face an uncomfortable question. When exactly does the Voyager mission cross its final limit? For as long as we've been human, we've looked up and imagined what lay among the stars. With the space age, fantasy turned into maps, and probes began turning the universe into a neighborhood. Among all missions, few symbolize the drive to go farther as strongly as the Voyagers. They are at once proof of human ingenuity and solitary messengers from a blue planet. Yet after decades of travel, failures accumulate, energy shrinks, and the silence of space approaches like an inevitable sunset. When they lifted off in 1977, the two probes were already bold for the technology of their time. The plan was relatively modest: survive long enough to fly by Jupiter and Saturn. Designed for a few years of operation, they defied the schedule, outlasted generations of engineers, and kept going, steady, beyond the heliosphere. But as much as they have beaten time, they cannot escape a non-negotiable limit. The engineering itself ages in the interstellar cold. That limit begins with the power source. Instead of solar panels, useless at great distances from the sun, the Voyagers use radioisotope thermoelectric generators that convert the heat from the decay of plutonium-238 into electricity. It's a slow, reliable flame, but not an eternal one. Each year, the electrical budget drops by about 4 watts. At the start, each probe delivered something close to 470 watts. Today, a little over half of that remains. In a system where every watt counts, the math simply won't add up forever. So the ground team has to decide what lives and what dies. Scientific instruments powered down bit by bit, systems put to sleep, heaters limited to the minimum. The priority becomes the essentials: keeping the spacecraft conscious, pointed, and able to speak. Speaking, by the way, is another colossal challenge. The Voyagers transmit through 3.7-meter dish antennas, sending radio signals so weak that their power at the source is comparable to a refrigerator light bulb. By the time they arrive here, after billions of kilometers, what we receive brushes the edge of the undetectable, a tiny thread of energy lost in the noise of the cosmos. To fish it out, we depend on the Deep Space Network, a trio of complexes with giant antennas in the United States, Spain, and Australia. Even with that infrastructure, the latency is brutal. Today, a command sent to Voyager 2 takes almost 20 hours to arrive. The response takes just as long to return. Any adjustment, test, or correction must be choreographed days in advance. In a mission like this, haste becomes error, and error can be forever. Inside, the situation is even more delicate. Each probe carries computers less powerful than a basic modern calculator. They're machines programmed in low-level language with minimal memory, kept alive by sheer creativity. Any update has to be transmitted with absolute precision. One wrong bit in the wrong place can compromise a subsystem for good. As decades pass, natural degradation takes its toll. Sensors fail, readings pick up noise, flaws appear that no one predicted in the 1970s. And even so, the team manages to extend their lifespan with ingenious solutions, reprogramming routines, redistributing power, improvising remote repairs. Distance, however, is a patient enemy. The farther away they are, the weaker the signal. The weaker the signal, the fewer data we can extract. There comes a point when, even while functioning, the probe becomes practically inaudible. Interstellar space is vast and indifferent. At some point, it will cut the Voyagers off completely. There are recent milestones that lay bare how narrow the margin has become. In 2020, a maintenance need at the Canberra complex in Australia left Voyager 2 without contact for 7 months. It wasn't the probe that had gone silent. We simply had no way to listen. In 2023, a slight misalignment of about 2 degrees in the spacecraft's antenna orientation was enough to temporarily compromise communications. And when the power that reaches Earth is on the order of billionths of a watt, any detail becomes a chasm. To prolong the mission, engineers have adopted planned shutdowns. Plasma science and charged particle instruments, for example, have already been turned off to save power. Each cut is a trade-off. We collect fewer data in order to keep alive the possibility of collecting any data. And it's not just the science that suffers. Heaters and redundancy circuits also go onto the sacrifice spreadsheet. The cold of space is an invisible corrosive, and sensitive components, without heating, continue to operate by a kind of disciplined miracle. At this point, the question may not be if, but when. Current projections suggest the probes should still be able to send scientific data until the middle of 2027. After that, the likely horizon is basic telemetry, heartbeats and breathing, so to speak, possibly until 2030. Past that threshold, the remaining power likely won't be enough to keep the transmitters on. That's what we can call the final limit of active communication, the instant when the spacecraft ceases to be an interlocutor and becomes silence in motion. And yet silence is not death. Even after they fall quiet, the Voyagers will continue on their trajectories, obeying the inertia that rules everything in space. There will be no explosion, no dramatic disintegration. There will only be the continuity of the path, lifeless objects crossing the Milky Way, perhaps still existing a billion years from now in some unimaginable corner. The practical end of the mission, then, is not an event of destruction, but the sum of two impossibilities: insufficient power and impossible communication. If you look back, you'll see the legacy is already secured. The Voyagers revealed worlds that were once only blurry smudges, showed gigantic anticyclonic storms on Jupiter, delicate rings on Saturn, and gave humanity a sense of scale that's hard to put into words. Today, they are the most distant human-made objects from home. When they fall completely silent, they will still serve a poetic purpose, wandering time capsules, carrying with them the story of a species that decided to ask the universe who it is. But we don't need to romanticize to grasp the beauty of what is happening now. What we see in the Voyagers at this very moment is the careful management of an ending. The team decides which instruments breathe, which say goodbye, which heaters get one last minute of warmth. Every command sent is a letter that may never get a reply. Every bit that arrives is treated like gold. The mission teaches us that technology is not just brute power. It's also the art of stretching the possible with restraint, negotiating with limits, and, above all, accepting that every grand project carries within itself the moment when it needs to be put to sleep. That doesn't mean the limits are arriving only because of distance. Distance makes it worse, but what truly builds the final wall is the sum of internal factors: the gradual loss of electrical power, the weakening signal, the shutdown of instruments, vulnerability to cold, and the lack of redundancies. There's a point at which the energy budget no longer pays for the basics: warming what is sensitive, keeping the radio awake, holding the antenna's precise orientation to aim at Earth with a surgeon's accuracy. When your margin depends on frugal heaters and lean gyros, any bump becomes an existential risk. Maybe that's why the truest image of the Voyagers isn't a spacecraft shining heroically in space, but a small silver disk cut out against a field of stars, spending watts with a monk's thrift, oriented with obsessive care, whispering to us. There is no grand spectacle in a whisper. There is, however, a strange and powerful dignity. When silence comes, and it will, the spacecraft won't turn into static memory. They will become questions. What kind of species invests decades to launch two artifacts that cross the sun's boundary and then accepts, without drama, that it is time to listen less and understand more? What kind of ambition measures success not by the volume of data still arriving, but by the fact that we managed to bring any data at all for so long? And what other story, 50 years from now, will remind us that science is a marathon in which sometimes the finish line is also an invitation to look at how far we've already run? If the Voyagers are the prelude to our dialogue with the stars, their end isn't a period but an ellipsis. They will go on, silent, carrying the proof that a small planet managed to touch the edge of the infinite. And we will go on from here, accepting that every exploration has a cost, every project has a last command, and every good story ends the right way, by leaving a question hanging in the air. After all, when the voice falls quiet, what can we still learn from the silence?